All right, Manik, thank you so much for being with us.
Thanks for having me.
So you have established this area of extreme classifications, and we would like to know what are the strengths of your solution.
So I think the way you measure the quality of an extreme classification solution is based, I think, on 4 parameters. The first parameter is accuracy. What is the accuracy with which you can make recommendations on that people will adopt, etc. The second is training time. So how quickly can you train your model, because that is really critical for carrying out lots of experiments and trying out new features and trying out new parameter settings, etc. The third is the speed at with which you can make predictions, because there are many applications where it is critical to make predictions in a few milliseconds. And also have, so that's just latency, but throughput is important as well. So you might have billions of ads on which you want to make predictions, and you need to then do that quickly. You can't take weeks or months or years. And the final thing is model size, which is how much RAM do you need in order to make your predictions. And if you need a lot of RAM, then you need to buy big expensive hardware, so your operating costs will go up. So these are 4 parameters, and they're all linked. So you can reduce training time, but then that will also reduce accuracy, or you can try and reduce prediction time, but that will reduce accuracy. So they're all linked, and they also have nuances, right? So for example, accuracy is just not one number. Accuracy is how not only can I predict things that you will like, but things that are new, that you might not have seen before, things that are different from the other recommendations that you're getting, so they have diversity in them, etc. So all of this is there. But I think, if I may, there's a different question behind the question that you just asked, right? And the fact that you choose to focus on the solution is interesting, because I think the most interesting thing, so many of us, when we do research, right, we first come up with a solution. Once we have the solution, we find a problem. Then once we found the problem, we try and find an application, right? Whereas I think when we're really doing research, the first question we need to ask is, where is the money, right? Or which lives am I going to save, or which planet am I going to put a human being on? So where is the impact? Once you figured that out, then you figure out what is the problem. Once you figure out what is the problem, then you figure out what is the solution. And so in extreme classification, I think my solutions will not be the most important thing. It will be the applications and the problems that will be more important. Yeah, I think people will come out with better solutions over time.
So I think I have questions related to that part, but I'll bring them later. But for now, I want to bring the deep learning in this context. So when you started extreme classification, deep learning was popular. So how did your community take your work, and did your work get appreciated right in time? And how did you deal with that, or there was no challenges?
I see. So there were a few challenges. I don't think any of them were related to deep learning. So I remember, like, I think the first 2 or 3 times I submitted the MLRF paper, it got rejected. But that had nothing to do with deep learning, right? It had more to do with me, right? So when you do something really new, you yourself don't understand it. And so you don't know what is the best way of communicating it, how to situate it in what's happening, and how to differentiate it. And because there's so many new things, you don't know which ones are more important and to focus on, right? So the reviewers didn't understand it, and of course I was not writing the paper as well as it should have. So it's probably fair that it got rejected a couple of times. But it ultimately got through, and things were fine. And then the talks were always very appreciated, like, because it was so new and so different from what everyone was doing. I think people loved the talks. They didn't initially like the paper, but that kind of changed, okay. And yeah, I think over time, I built a community around this, right? So we went and released the extreme classification repository, where we have code, data sets, results, etc., right? So that makes it very easy for new people to come in. So more people, the bar for entry is lower. And also the fact that we've standardized everything, right? So earlier on, people would just take one data set, one algorithm, publish it, and say, look, this is good, and etc., right? So you weren't really you didn't know whether the field was making progress or not. Now you have a standard set of benchmarks. Here are all the algorithms on all the data sets, and see whether you're making progress, etc., right? And we set up workshops so that people could come in and discuss ideas, and that helped in establishing the community. I went around giving a lot of talks and stuff. So I don't think there were any real challenges that we couldn't overcome or anything. I think it's been a really fun journey so far.
So you talked about progress, but what are the challenges of machine learning concerning your area?
Yeah, so I think I personally tend to think of machine levels. There are various levels of machine learning, and I think you can have big challenges in all of them. And if you look at the research that is being done all over the world, it's addressing these challenges precisely, right? So I think in classification, if you look at it, I think you can do 3 or 4 different things, right? You can train on a large number of data points, so that becomes distributed machine learning. So you have lots and lots of data points. Or you could have very high dimensional features, that becomes high dimensional statistics. You could have a very large number of categories or labels, so that is extreme classification. You could try and learn new types of features and representations, so that is deep learning, right? And then you could have all of this at the opposite spectrum, right? You can have very little training data. Then you do domain adaptation or transfer learning, or you could try some of these Bayesian techniques. Or you could have very small model sizes, in which case you're going to resource efficient machine learning. So at that initial level, there are all of these things. And then of course you will also have things outside classification like unsupervised learning, semi-supervised learning, reinforcement learning. All of them will be challenges. But I think if you go one level above that, right? So I think machine learning is primarily dealing with correlations. But you could ask counterfactual questions, which would be one level higher, right? So here is the data set I trained on, but if I'd been given some other data set to train on, then what should my predictions have been? Or here is how I'm evaluating my current method, but if the evaluation method was different, what would my predictions have been? So counterfactual questions like these what if questions are one level higher, which people are interested in. And then one level above that is causality, right? Which is not just correlation, but what was the real cause of this phenomena? If you can understand that, then that can be helpful. And then of course there's the uber goal of artificial general intelligence, like build something that can just do everything, match human ability, etc. All of these are grand challenges at different scales. There are big problems in all of them.
So you talked about, if you do everything and all, so outsiders might have this question that machine learning seems to be, working more on predictive models like for Facebook, Amazon, and etc. So with machine learning, you can do new kind of science? Can it lead to new science, new knowledge?
Yeah, absolutely. So I think we were just discussing this a little while ago, right? So with biology, I already gave 3 examples. So doing like personalized medicine, having kind of figuring out what are the causal effects of when we sequence the human genome and figure out, okay, which genes are responsible for which diseases, etc., and trying to then build medicines around that, reprogramming the DNA and stuff, and also the HIV vaccine, right? So all of that is happening. In addition to all of that, I think, so John Platt gave a really interesting keynote at NIPS where he was talking about powering the next 100 years or so, right? And he wants to have every person on the planet access to as much energy as the average US individual, etc. Right? So how are you going to do that over the next 100 years as the population increases? You can't rely on fossil fuels because they're going to run out. And even if you burnt all of them, then the amount of carbon dioxide in the atmosphere would just shoot through the roof, right? So he's looking at zero carbon technologies and seeing how machine learning research can help accelerate the research in these areas like fusion, etc. And so that was really interesting. And people are trying out lots of things in astronomy as well, right? So Bernard Scholkopf has been looking at these causal machine learning and how that can avoid systematic errors in astronomy. And I think his team has been working with astronomers and they've helped discover some planets as well. And I remember they were studying gravitational waves. And again, he has a keynote at ICML that you could look at. And later on this year or early next year, I'll be going to Berkeley and working with the astronomy department over there. So I also hope to kind of learn new things and contribute in that area. It's not just Amazon and Facebook. Yeah.
So you said, there is a possibility you can, can imagine world with zero carbon emission. at some later point. But how can machine learning, when we come to Indian scenario, so can machine learning help solve India's problem, and are we already working on them?
So India has a range of challenges which from a machine learning perspective could be thought of as being very exciting, right? The possibility for impact is very high. I mean, so for example, look at the fact that if we could enable any two Indians to talk to each other or communicate with anybody else in a foreign language, in English or right, the barriers to education, to employment, etc., would come down tremendously. So if we could build a system that could do translation, right, machine translation, and have the voice be rendered in the person who's speaking in his voice, etc.
In real time.
In real time, that would be a major game changer, right? And people are working on different aspects of this, I believe, and I think like Professor Hema Murthy at IIT Madras, she showed a demo of a system which is slightly different, right? It doesn't do the translation, but a farmer in rural India can just call into a mandi and ask the price of how much are vegetables selling for in his own local language, and so then he can determine which particular mandi to go and sell his produce to. And I know Jawahar at Triple IT Hyderabad, he's working on Indian language OCR and stuff, and other people also working on. And then some of the stuff I showed could be helpful, like we're looking at precision agriculture. A farm is not homogeneous, right? So because we have such shortages of water and fertilizer and pesticide, etc., you can figure out which bits of the farm need irrigation and which bits don't, and just irrigate that part of the farm, or just spray pesticide on that part of the farm, etc. And I think the land holding in India is small for doing precision agriculture at scale. But there are other parts of India where this is not a problem, and people can come together as a community to do this. I think Microsoft is partnering with people in GKVK, I think Grami Krishi Vidyan Kendra, and they're piloting a few things to help people in agriculture. So the scale is enormous, and I mean, of course in metros you want to have smart electricity, smart housing, smart like driverless vehicles. All of this will be very helpful for India.
So I think it brings me to the next question. You answered half of it already. So students trained in machine learning, how are the job prospects? Like, what are the in academia and in industry? So listening to you seems like a lot, but what's the ground reality?
So academia, I think it's fairly standard, right? You have IISc, you have all the IITs, you have all the new IITs and NITs and JNU, Delhi University, all of these will be your standard options, I guess. In industry, I think the scene is actually fairly good. So a few of my PhD students have received offers of more than 1 crore, like significantly more, right? Which is, I think, a very good thing. So if you pick the right advisor and you pick the right problems to work on, and you do world-class research on them, where you're not just publishing in top-tier conferences, but those solutions actually have value, and as part of that you pick up skills that are important to industry, I think you can get very good job offers, right? So there's Google, Microsoft, Amazon, so these are multinationals. The big Indian startups are Ola, Flipkart, I guess now Walmart. And you have the traditional Indian companies, Naukri, InfoEdge, etc., right? So the possibilities are fairly bright, and I think like even if you're not interested in a PhD, I think one of my BTechs from IIT Delhi, I think he got a package of about 40, and I think he's interested in the work, and this is interesting work, it's not just drudge work. I think one of my master's students, masters by research, he got an offer about 26, but I think she was not very happy with the work. So I think there's a spectrum of quality of work and compensation, and you can choose to play on the spectrum where you want to.
So in the beginning you talked about like thinking of application first and then solution later, and you are simultaneously working with Microsoft and IIT Delhi. So what, in your personal opinion, what difference do you see in research at an academic institute and an industry?
I see. So I think they both have their strengths and benefits, both academia and industry. I think I value 4 things in industry. The first is access to data. If you're in a large corporation like Microsoft, you have access to a lot of data that you typically would not have access to in academia, right? And so that can be a big difference in machine learning, at least. So that's the first point. The second point is, not only do I have access to data, but I have access to problems. So by talking to our product groups, I can go and figure out what are the pain points today. I can abstract out a research problem from there and bring it to the machine learning community and get people to solve it. And that's what happened with extreme classification. And people can do this in academia too, but sometimes it's less real, right? So if you think of a problem in your bathtub, there are chances that you would have missed important, you would not have thought about important design choices or important settings of the problem, which might not make the problem last or have impact in the world, right? So that's the second thing. The third thing is the ability to have impact. If you're at in an industrial research lab, you can reach millions of people and try and improve their experiences daily and try and build, let's say, things that will improve their security or their privacy and stuff, right? So that's, which you cannot do in academia. So that's the third thing. I think the fourth thing that I value in industry is mentorship. So in an industrial lab, I have a manager or a mentor who is actively helping me and criticizing me and saying how I could improve. Whereas I don't have a person like that in academia, or people generally don't have that in academia. So, and that's been incredibly valuable for me in my career, at least. So those are the things that I value in academia and in industry. And in academia, I think you have students who are really eager and very bright and very motivated, and being with them and talking to them is a very good experience. And so that's something I value. And also in academia, you have long-term stability, right? So in industry, you will be influenced to market forces and things will change and very dynamic. And that can be both a positive as well as a negative, right? Sometimes as a researcher, you want stability and you need to have a very large horizon where you don't want to be influenced by changes in the industry. But then sometimes you lose flexibility and agility because of that. So yeah, those are the main differences, I think.
Very well said. So, but we both are important component of our society. So do you see we have enough enough interaction between academia and industry, because we need that, right?
Yeah, so I think we have some existing mechanisms. So I think industry takes interns, they sponsor PhDs. I think they also have these I think Google, Microsoft, IBM, TCS, they all have these fellowship programs. And I think NASSCOM and FICCI, they also do a little bit of thing, right? So on the whole, people from academia go to sabbaticals in industry, etc. So all of that is there. I think the place where you could improve is at the root cause level, right? So I think many people in academia are not looking to have industrial impact, right? For them, the academic system is the be all and end all. And that's fine, right? Like when I started out being like that, right? Because both my parents are academics and I've always valued that, okay, yes, you need to get papers and influence people that way and stuff. But it's only after I joined Microsoft that I realized that, there's this whole other level of impact that you can have on the real world and stuff. And people might not realize that, right? So there must be some ways to actually show them that this is possible, give them incentives to do this, etc., right? And at the same time, industry also often thinks that, why do we need research, right? All these people are publishing papers, they're just academic, they don't really work in the real world. I have a 3-month deadline in which I have to ship my product. I want something that works immediately and I need a solution, a practical solution. So I think both sides need to see value in the other. And I think that's when you'll have much stronger ties, if we can enable that at the root cause level.
And now coming to your personal journey in this area, you had started with computer vision, right? And then you moved to machine learning in extreme class. So how was this transition? Was it difficult, easy?
So it's I don't know whether it's difficult or easy, but I remember that like all through my PhD, postdoc, etc., I'd been working in computer vision. I was designing features for texture to see, like, to be able to recognize materials in images. But then some of the machine learning techniques that I had been developing proved to be useful for other things as well. And so I was starting to do this machine learning research, but still publish in the computer vision community because I was in my comfort zone, right? And I was just happily motoring along. And then I mentioned mentorship, right? So my manager told me that, look, I mean, we would value you as a researcher, not just a computer vision researcher. And if you moved out or beyond the computer vision community, your work might have impact in other communities too. So he kind of encouraged me to look just beyond computer vision, and then I started publishing in machine learning conferences, and the extreme classification happened. And because it was having so much impact, then my computer vision, that aspect of my research, that the significance of that came down. And again, with extreme classification, you could potentially apply it to computer vision problems, or even with the IoT thing, right? So we could come back to computer vision, but right now, because this is having so much impact, I'm focusing on this. In terms of the difficulty of the transition, the main thing I felt was like I have no mentors or group in the network in the machine learning community. I inherited a group from my supervisor or whatever, or contacts while I was doing my PhD, etc. Right? So I knew people in the computer vision community. I didn't in the machine learning community. But that's just been like fun, right? Because I have to go and introduce myself to people and talk to them and make friends and build my own network, and that's fine.
So then now the follow-up question is, I mean, how do you choose problems to work on?
Yeah, so I already mentioned, right, about the impact thing, right? But I think there are three things that are at tension with each other. So there is impact, there is feasibility, and there is interest, right? So you could choose problems that have a lot of impact, but they might not be feasible, right? So for example, if you might say, I'm going to solve P is equal to NP because that will have a lot of impact. But at least for me, that's not feasible, right? I don't have the training or the skill to solve that kind of problem. So I have to kind of balance impact with what is feasible. And even if you think it's not feasible, that's fine, right? Because then you have to mitigate the risk. You have to set up or break the problem into parts so that as you make progress towards that final goal, the intermediate results that you generate or accomplish or that you get, those have value in themselves, right? You'll either learn something or you'll produce something of value along the path. And you mitigate risk that way and make it more feasible. And then of course there's interest. If there's personal interest, then yeah, those are the three things I look for in a problem.
So a lot of the problems you solved are quite risky by definition. So with the risk comes success and high chances of failure. So how do you deal with failure, if at all you had?
You just redefine success, right? That's the standard answer to that question. So I think it depends on what you yourself mean by success or failure, right? Often I find that I learn more from failure than from success. So each of my failures has actually taught me something very important, which has proved to be very useful later on down the line. I think especially in our culture, both in academia and Microsoft research, we're very tolerant of failure, right? We're encouraged to take risks. We're not encouraged to work on short-term engineering problems where the solution is known, the problem is, you just have to implement it and get it done, right? So in that sense, we are fairly, I mean, we're treated specially, we have privileges so that we can take this risk, and I think it's our duty to take that risk as researchers and as academics. I think so for failure, for myself, I'm not that worried because, as I said, I have a long time horizon and I learn things, and ultimately those failures are very important. Where I'm more worried is for students, right? So if you take on a big risky project where you don't get publications or you don't get demonstrable impact, then less than my career, it's a student career that suffers, right? Because he needs to do his PhD in 5 years and have 6 publications or however many, 3 publications and that have a lot of impact and stuff. And there I think we have to kind of adjust the expectation, because people today are, because of that rat race, they're doing this like least publishable unit or least transferable unit kind of work. And that I don't think helps anyone. So, but that is a problem that the whole community needs to fix. I can't just fix it by myself. But yeah, that's an important thing we need to look out for.
So Manik, this is a very personal question. I hope you don't mind me asking. So you are in academic and research, and both require, so for teaching you have to be on board, and for research you have to keep up with the research material, read papers. And with your failing eyesight, how are you, managing this change? And are you taking help from technology? I'm sure you are, but can you share that with us?
Yeah, I mean, it's no big deal. It just makes life more interesting, right? So yeah, I have taken help from technology. So there was a point. I think the first technology I used was a white stick. So when I couldn't see anymore, then that helps me walk. And then I lost my eyesight further, and so I couldn't read papers. So I started inverting the font and then making things very big, and then that went also. So then I got a screen reader that would read out things to me, but that can only read out regular English things, so like email and stuff, but it can't read out maths. So that's a big pain. But so then I ask for help. I'm very besharam in that sense, right? I'll ask my students for help. They'll read out the papers for me, and it benefits both them and me, right? Because they'll get to learn about the paper, and I'll get to obviously also learn about the paper. I'll help them, ask them for help in making slides and stuff, and so they learn how to structure a talk and how to present a talk and stuff as part of that. And then of course I also benefit. And for example, like just setting up this laptop, I couldn't do it myself, so I asked you for help and stuff. So I don't think it's a big deal, but yeah, I've relied on technology, and I'll have to rely on it going forward. And I think many people actually face such issues. It's just that with me it's more visible than with some of the other people, so it's no big deal.
So has it changed you somehow, in terms of the questions you will ask in research, or have you changed the way you think about what you'll accomplish in next phase of life?
I've definitely changed, but not because of my eyesight. I think I've learned a lot from my colleagues, from my students, and from my managers, and that has been the main cause of the change, not so much the eyesight. For example, I'm not abandoning my research career and focusing on developing let's say tools for the visually impaired, though that is a very important and a very interesting problem. And actually one of the things that we're doing could be helpful in that. So we're taking some of the research that I just discussed and building an interactive cane which you can use, like, so it'll recognize the gestures that you perform on the cane, and then it can interact with a device like your phone or some other device, that so it can read out, it can tell you what is the time, where you are, what's your location. It can read out your mail and notifications, and you can control other aspects of the device with it. So yeah, I don't worry about it too much, and that particular thing has probably not changed my life professionally. There have been some changes I've had to make in my personal life, and like helping with kids' homework or doing jobs around the house, etc. And there I'm very grateful to my family, but professionally I don't think there's been that much change.
I think with this, Manik, I will really like to thank you so much for your time and being with us.
Oh, the pleasure was entirely mine. Thank you.
Thank you.
Cheers.